Okay, today I'm going to be showing you how we can create this hex grid, and then I'll quickly show you one way you can create a cool pattern like this and then animate it as well. So the first thing we can do is, for example, take a look at something that's less challenging, which is how do we tile a bunch of octagons. So for the octagon, it's almost exactly the same node group as the hexagon, except here we're using pi divided by 4, which is 45 degrees, which is so that we get this line, and then we compare it with the x-axis and with the y-axis. So here, taking the dot product, and then with the x-axis, and then here with the y-axis, and then using a less than, I'm changing the width, which is another input. So to tile this, we first scale our plane so that everything gets multiplied by 10, and this point, for example, is 10, 0, with x being 10 and y being 0. Then we take the fraction so that everything goes between 0 and 1, and fraction is the same as doing modulo 1. So it's like dividing everything by 1 and then taking the remainder. So it's basically taking the decimal part. I've already explained this multiple times. And then I'm subtracting 0.5 to make the center be at the center, as you can see. So moving the origin right here. And then when you plug this vector into the octagon, each of these ones is going to produce an octagon, and then we get this, and that's how we tile it. This is 4 nodes, very simple. So for the hexagon, we need to do something a little bit different. So one thing you can do, I've named this node hex grid bad because it's a bad idea and it's really complicated. This is what the node setup looks like. And what I did here was I made 4 copies. So I made one here and then another one here, because when you make a square, so let me show you. Let's just take a look at this. So as you can see, the top of the hexagon is touching the sides. So if I scale it further, the top of the hexagon will disappear. That's why I needed to duplicate it to make them tile next to each other, which is what this part does. Or the other part, I can mute one of them, so you can see that they're now tiled to each other. And then I did the same thing on the bottom, but then with an offset, so that instead of starting at this place, it starts here, and that way they line up perfectly. And the ratio I used here is, again, here I used 30 degrees and then took the cosine, which is square root of 3 divided by 2. And this is the ratio I used, which is based on mathematics, which is not really important, but that allows you to perfectly align the hexagons. As you can see, the node setup is really horrible, and if you wanted to change something, it would be difficult. So the next thing I did was this second node group, and the idea here is sort of similar, except that now to tile it is a lot easier, because I'm using another property of hexagons. Yeah, if you have this point and this point, and then take all the points in between them, and then check to which point, for example, if you look at this point, this is closer to this one than it is to this one, so it's part of this hexagon. And by comparing all the distances, you can create hexagons. So this is like a Voronoi pattern, except that you have to choose the position of the points carefully. And so what I did here was, so we have this node, so this is, the grid is tiled to multiple places, or yeah, it's tiled, and then it's tiled here but with the same offset so that they're there. And then I'm taking the dot product with itself to get the length squared, and I don't need to take the square root because I'm comparing both of them. Since I'm comparing two dot products, I don't need to take the square root, which makes it a bit faster. And then I can use a greater than, and this will give me, tell me which point is closer, and then I can use that as a factor to mix both of these together to finally get our grid. So let me copy everything. Sorry. And paste it here to show you what I mean. So I'll just take this UV and plug it into our vector, and then set both of these to 10. So now I can actually show you what I was talking about. So the first thing we do is we multiply, like with the octagon, to get a tiling again by 10. Let me turn off bloom because it's going crazy. And then I separate it to make tiling, but the tiling along the x-axis is different for the tiling along the y-axis. As you can see, there's less along the y than there is along the x. And this is because a hexagon isn't as thick as this long or tall, I don't know. So as you can see, they have a different height proportion, and this way our hexagons will be perfectly shaped. I mean, they'll have a, how do you say that? They will be regular and their side lengths will be the same. And so I do the same thing here, except that I first subtract so that we have the same thing. If you can see that one of them is shifted up, or is shifted over, so that so that they're not in the same place. And so each of these points is the center of one hexagon. And then if you take the dot product, we get the length, but then squared. So you can see this is already looking like Voronoi, but not really. The same thing here. And then if I take greater than, you can see we get a sort of factor that we can use to combine both of these. So this tells us whether this one was closer or this one was closer. So if it's white, this one was closer, and if it's black, this one was closer. And when we use this as a factor, you can see I'm actually overlaying this onto this so that we get our hexagons. And that's how we get our hexagons. Now there are two more outputs to this node group, and one of them is this one. And this is just useful if you want to make the hexagons have a smaller size. And this is the exact node group, or the node group that we created in the previous video. And then in the end I multiply here by 2 so that this one is, the distance here is 1 from the origin and not 0.5, which makes it more user friendly. And then the last output here This one is useful if you want to create random patterns. So this tessellates or pixelizes our grid, but then uses the hex coordinates that we had into discrete points. And then if we plug this into a noise texture, we get random values for each hexagon, and that way we can get random colors. Because if we only have this, all of these will always have exactly the same values, and so we need to use this. The math for creating this pixelite version is exactly the same as here, except that now we use ceiling and floor to create. So as you can see, we also divided the grid into two parts and then use this factor to combine them together. And then in the end I divide so that this is in the 0 to 1 range, because now it's in the 0 to 10 range, which is not what you want usually. You want everything to be in the 0 to 1 range. So that is, I named this one mediocre because there's still a lot of nodes, and we can actually simplify this a lot using more vector math. So let me just delete this. So the final node is going to be this one. Now I'll try and find a way to share this blend file with you so you can use these nodes in your own projects if you want. I don't know yet, but I'll probably put it in the description or write a comment showing you where you can find it. So here I've also added frames to make it clear, and as you can see there's a lot less nodes compared to this one, but it does exactly the same thing and it's exactly the same math, except that now we're using vector math. So here we have a ratio of width and height. So again, this is the square root of 3. So if our hexagon has a width of 1, then its height is going to be square root of 3. That's why we have this ratio. And that we then here this is the tiling. So we have our how much we want to tile along the x-axis and along the y-axis, and then we multiply everything by that, and that way we can again repeat our grid. And so we have our first nodes, which are the bottom ones. So let me just turn the ones right here, and then we have our second ones, which are the ones right below it. And in the same way we take the distance and then use this factor to separate them out into the hex coordinates. Then here, instead of using all those nodes, I just use the node group that we already made to make it a bit more compact. And so the difference is, in the other part I first split it into x and y, and then divided the components separately, but using this divide node and subtract nodes from the vector math, where you can multiply entry wise, you can do the same thing, except that you don't have to split everything. And also in the other one I use modulo, which is usually you can do the same thing with it as fraction. So in this case, using fraction takes a bit less nodes and we get the same thing. So here you can clearly see the similarities between this one and the pixelated version. So for the pixelated version I'm using the ceiling instead of the fraction, and then for the hex coordinates I'm still subtracting 0.5 to put the center in the center where it should, where you expect it to be, and then here multiplying again to put it into the 0 to 1 range, I think. And then the dot product just like in the other one. And So yeah, I hope this is clear. It's okay if you don't understand anything. And so yeah, check out the nodes and tell me what you think. Yeah, so I promised you as well that I would show you how we can create this pattern. And this is just to show you why we need all three of these. So, well, in this case I actually don't use the hex coordinates, but for example, if we have our noise texture, and then let me cut off the links. So it's compiling here. So as you can see, this is our noise texture, but this is very detailed. I mean, it's not that detailed because I set the detail low to make it a bit faster. But as you can see, it's not discrete. I mean, it's continuous. So one thing you could do is plug this into here, but then with this set to ceiling to make it separate. But since we have our pixelate node, we can use this instead. And now you can see that each hexagon gets a separate value. You could use a white noise texture, but then it's gonna be completely random. And if you want to animate it, it's better to use something like a noise texture, where the numbers or the values change smoothly in between, and you can use the 4D noise texture to move it around in a 4-dimensional noise space to make it have a smooth transition between the different random values, which is different when you use white noise. It's just completely random and it looks jittered. It gets weird. So then I'm using this as a way to choose our color from the color ramp. So now we get the different colors. There you go. And then I plug this into an emission. But this doesn't look that, I mean, it looks okay, but it's not as great. Let me turn, it looks better with bloom, but it's not that good. So then I use the hex border, this one. So this is basically a tiled version of our hexagon node without the coordinates. And using a less than, I'm setting the width of this, as you can see. So I'll just set this to 0.87, I think it was. And that way we get a sort of border around each hexagon, and then I mix our emission shader with a transparent shader using this, so that we see borders around each of the tiles and it makes it look more futuristic, I guess. And then yeah, just using EEVEE to get it in real time, the lowest settings. And then to animate it, I just added a driver here to using the frame. So for example, if you want to animate, just let me delete this driver. So now it's a constant value, so 1 for example, and nothing happens. If you want to animate it, you can type something like #frame, and what that does is it just takes the frame and puts it in there. This hashtag is to indicate that you're making a driver. Then if I want to change it later, I don't need to put a hashtag anymore. But now you can see that it's the frame, but this is way too fast, so maybe I want to like divide it by 1000 or 100. I don't know what I typed. 100. Now you can see that it changes a lot more slowly. Then what I did is I took the sign of this and made it periodic so that it loops perfectly. So as you can see, I took the sign here and I made it loop every 120 frames. So now you can see that you just look at this, there's no clear point where it, I mean, it loops perfectly. So yeah. that's one thing you can do. You can do lots of things with these. Yeah, using these three, you can create lots of hexagonal tatting patterns. So yeah, thanks for watching.